Hello class, this is Mr. Parsons here. I just want to take a few minutes to talk to you about graphing functions. Okay, so let's take a look at these functions. And so just by looking at it, we just want to look at some initial things here. So we got 2 times x. And so looking at this here initially, we're just finding the product of 2 and x. But x is just raised to the first power, all right? If I look at b, g of x equals x to the second power. Well, this is x, the variable, raised to the second power, just by observations. Here I got h of x equals 2 to the x power, and so the variable x is the exponent. All right, so looking at this, we want to translate this into our graphing functions. So let's explore these functions here. F of x equals 2x. So you could make a table, and basically what you can do is you can substitute each one of these numbers for x. So like -2, I do 2 times -2, 2 times -1, 2 times 0, 2 times 1, 2 times 2, and then I get my output. All right, so when x is -2, f of x is -4, x is -1, f of x is -2, and so forth. All right, so that would be my output if I complete this table. If I plot each one of these points, because remember, f of x is the same thing as saying y. So -2 and -4, that's an ordered pair. -1, -2, 0, 0, 1, 2, 2, and 4. If I plot these points, I will have this. Also, you can input this on a graphing calculator that I will show you if you're in class how to input this in the graphing calculator as well. But this is how the graph looks when we plot our points. Okay, same thing for g of x, x to the second power. So I substitute -2 for x, -1 for x, 0 for x, 1 for x, and 2 for x. And then when I do that, I get my output. And so this is what I have. And so then your order pair is -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. And if I was to plot these points, this is what I would have. This is what our graph will look like. And then for c, I got 2 to the x power. All right, substitute -2 for x, -1 for x, 0 for x, 1 for x, 2 for x. All right, and then that gives me my output. So these are my order pairs: -2 and 0.25, -1.5, 0, 1, 1, 2, 2, 4. And if I was to plot these points and graph it, this is what I have. So let's look at number 2. All right, let's look at number 2. It says, so if I'm looking at each of these graphs, is it a function? Is each of these graphs a function? And so yes, we could determine that it's a function, because if you do the vertical line test, it will only intersect one point by doing the vertical line test. So since it passes the vertical line test, we could say that each one of these graphs are functions. Now, how can we evaluate f of 2, which is this function, and g of 2 only by using graphs? Now, we talked about this here in the previous lesson. So all you have to do is find your x value, find 2 on the x-axis. So this is 2 on the x-axis, all right, and see where it intersects the graph, which is here. And then we look at the corresponding y. So f of 2 is 4. Same thing for g. So this is 2. See what it comes to our point right there. Look at the corresponding y. The y is also 4. So both of those are 4. All right. So we find the value of y when x is equal to 2. That means you find 2 on your x-axis, see where that graph connects, and find the corresponding y value. Now, graphic calculators, again, we're going to do this in class, but just to give you some steps of how you can input it in the graphic calculator, you enter the function by, and this is with our TI-83 or TI-84s. Those functions are the same, but in the top you'll see a y equals button. All right, and then you just type whatever the function is, and then it's a graph button on that same row, and then it'll show you how the graph looks. How do you view a table? Second and graph. When you hit second and graph, it'll list the tables with your x and y coordinates on that particular table. How do you change the portion of the graph to zoom in and zoom out, you just do window and type in the parameters that you want to see it in. All right, but usually if you leave it in default, you're okay for the most part. All right, let's take a look at number 4 through 6. So if you was to graph this on your graphing calculator, which I'll show you in class, all right, then this graph, the square root of x, looks like this. Okay, and so what does the observation of this graph is? It's in quadrant 1, and it's like an arc. So it says evaluate f of 4. So you substitute 4 for x, because this is the function. The square root of 4 is 2. So therefore, f of 4 is 2. Let's look at number 5. This is saying the cube root of x. So if we was to graph this in our graphing calculator, all right, the cube root of x looks like this. And so the observation of this graph is that it is shaped like a flat S curve. We want to evaluate -8, f of -8. So we substitute -8 into the function. So the cube root of -8. The cube root of 8 is 2. So the cube root of -8 is going to give you -2. All right. Now, let's look at number 6. The absolute value of 3x. So we input that in our graphing calculator. It looks like this. And so the observation here is it's a V shaped above the x-axis. So we want to evaluate f of -5. We substitute -5 for x. So 3 times -5 is -15. But it's the absolute value of -15. And remember, the absolute value is the distance between that number and 0, which is always a positive number. So you're just seeing how many spaces it is between 0 and -15, and that's 15 spaces. So your answer here is going to be 15. All right, let's take a look here. We want to mark each statement as true or false. The graph of g of x equals the square root of 7x will be contained in quadrant 3. So if we input this into our graphing calculator, the y equals, and then you do the square root of 7x, we will see that it's actually in quadrant 1, not in quadrant 3. So A would be false. Okay. If we look at B, the graphs of h of x equals x plus 5 contains these points. So the way you can determine if this is true, look at your ordered pair. Your first number is x, your second number is y. So let's look at the first point. If we substitute 0 for x, 0 plus 5 is 5. That's right. If we substitute x for -3, -3 plus 5 is 2. That's right. If we substitute x for -9, -9 plus 5 is -4. That's right. So B is true. All right. Let's look at C. It says if f of x equals 1.5 to the x power, then f of 9 equals 13.5. So in other words, we substitute x for 9 and we do 1.5 to the 9th power. It's saying that 1.5 to the 9th power gives us 13.5. But if you do 1.5 to the 9th power, you will actually get 38.4. So this is false. Okay. And then number 8, it says Remy and Marcus graph p of x equals -x squared and r of x equals the absolute value of x minus 6 on the coordinate grid and make these statements below. Which student make an incorrect statement? So Marcus says p of x is shaped like an upside down U and r of x is shaped like a V. Okay. Remy says both graphs are located above the x-axis. If we was to input both of these graphs into a graphing calculator, we would see that actually Remy made the incorrect statement because p of x is below the x-axis, and we know that because it's -x. Since it's -x, it's going to be below the x-axis, not above the x-axis. So Remy made the incorrect statement. So with graphing functions, all right, we're using the help of our graphing calculator to do that. We're still evaluating our functions by substituting a given number for x into the function to give us our output. We're now just looking at how our graphs look, given our characteristics of the graphs, and being able to evaluate our functions from the graphs. and from the graphs we could be able to solve problems and answer questions. So I hope this helps with our understanding of graphing functions.